Hurricanes. They're one of the most deadly and destructive forces on Earth, causing unfathomable damage, uprooting lives and trees alike. The storms that come close to land often necessitate mass evacuations, destroy developments and homes, cause flooding and severe weather, and displace millions of people. Particularly severe and destructive hurricanes remain in public memory for decades, like Hurricanes Katrina, Sandy, and Harvey, to name a few. Hurricanes originate in the Atlantic Basin, which consists of the Atlantic Ocean, the Caribbean Sea, and the Gulf of Mexico, as well as in the eastern North Pacific Ocean. They can also form in the central North Pacific Ocean, though formation is less frequent there. While hurricanes are fierce, intense storms that seem like they could pop up anywhere and wreak havoc across the entire tropics in one fell swoop, for some strange reason, hurricanes almost never form at the equator. In fact, it's extremely rare for them to form anywhere within a few degrees of the equator, with 1 degree of latitude covering about 69 miles or 111 kilometers. And not only do tropical storms rarely form at the equator, but hurricanes also almost never cross it either. So why aren't there hurricanes at the equator? What makes the area around 0 degrees latitude one of the safest places on Earth from these super violent tropical storms? How is it possible that hurricanes would not consistently form or cross this region? Let's get to the bottom of this utterly bizarre phenomenon. The United States and the Caribbean are frequently hit by violent and destructive hurricanes. Over just the last 30 years, these storms have caused billions of dollars of damage, displacement of millions of people, and countless casualties. Also sometimes called typhoons or cyclones, hurricanes actually fall under the scientific name tropical cyclones. The hurricane is said to have gotten its name from the Taino word hurricán, who was the Carib god of evil. The Taino people were the indigenous people of the Caribbean and Florida, which are areas historically hit by lots of tropical storms. The Carib god was derived from the Mayan god of wind, storm, and fire, named Hurricán. When Spanish colonizers passed through the Caribbean, they adopted the word hurricán to describe the natural phenomenon we know today as the hurricane. So then why today do we refer to hurricanes mostly by first names? Hurricanes occur on average 12 times a year in the Atlantic Basin, with most typically appearing between June 1st and November 30th, which is known as hurricane season. Because these storms can last for weeks, and multiple storms can take place at the same time in the same body of water, scientists have taken to giving the storms names to reduce confusion about which storm a forecaster is referring to when addressing the public. In the early 1800s, tropical storms were named for the saint's day, during which it occurred. In Australia, during the late 1800s, meteorologist Clement Wragg began giving traditionally female names to storms. The military meteorologists of the United States adopted this process in the Pacific during World War II, and the U.S. formally adopted the method in 1953 after first considering naming hurricanes with the phonetic alphabet, with names like Abel, Baker, and Charlie. In 1978, traditionally male names began to be implemented too, and today feminine and masculine names are alternated. The World Meteorological Organization currently has a rotating list of 6 years' worth of names, which repeats names every 7 years. Names of storms that cause significant loss of life or damage to property are retired though, because bringing back such names may prompt painful and traumatic memories for impacted people. In other areas, tropical cyclones receive names unique to the basin in which they exist and the regions they affect. Names are often borrowed from areas of the world that the storms affect. For instance, in the Northwest Pacific near China, Japan, and the Philippines, tropical cyclones often receive names common to Asian cultures, including names of flowers and trees. But what even are hurricanes? Tropical cyclones, which include hurricanes, are rotating, low-pressure weather systems with organized thunderstorms but without fronts. A front is a boundary that separates two air masses with different levels of density. Hurricanes tend to form in tropical seas where the waters are above 26 degrees Celsius. This is because tropical cyclones need warm ocean waters as an energy source, background spin, and low vertical wind shear, which is a measure of the change in wind speed and direction with height in the atmosphere, to form. But not all tropical cyclones are hurricanes. Tropical cyclones with maximum sustained surface winds of under 39 miles per hour are called tropical depressions and tend to be less severe than tropical storms, which have maximum sustained winds of 39 miles per hour or higher. A tropical cyclone only reaches hurricane status once it reaches 1 minute maximum sustained winds of at least 74 miles per hour, and it must be over the Atlantic Ocean. The intensity and severity of hurricanes is measured by its maximum sustained wind speed through what is called the Saffir-Simpson Hurricane Wind Scale, which operates on a 1 to 5 rating scale. These ratings are called categories, which you've probably heard a newscaster use when describing a hurricane, often shortening them to CAT. These categories help describe the hurricane's potential for damage. With the higher the category, the more likely it is to be destructive. So where do they come from? Originating in the Atlantic Basin, hurricanes form from the warm, moist air above ocean waters near the equator. As the warm air rises, it creates a region of lower air pressure underneath, and nearby areas of higher air pressure push into the area with lower pressure. That air then begins to warm and rise as well, creating another low-pressure zone that more air gets pushed into, and so on, repeating the cycle. The air that rises will eventually start to cool down, and as a result, the water in the air forms a group of clouds. These clouds will begin to spin from the cycle of swirling air flowing into the low-pressure zones, and eventually, these spinning clouds will grow into a cyclone. The cyclone is fed by the heat and evaporating water of the ocean. This creates the immense and devastating natural phenomenon we know as hurricanes. Hurricanes are made up of 3 distinct parts: the eye wall, and the rain bands. The eye of the hurricane is a round area that can range from 19 to 40 miles in diameter. You may have heard someone say that they feel like they were in the eye of a storm before, meaning that they were calm and peaceful amidst chaos around them. And this expression aptly describes what being in the eye of a hurricane might be like. A generally peaceful and calm area surrounded by high winds, heavy precipitation, and intense thunderstorms. But since a hurricane is moving, your time in the safety of the eye is limited, and soon you'll pass into the eye wall. The eye wall of the storm is where the strongest winds and rains are. It's a ring of thunderstorms that surrounds the eye of the hurricane. And then there's the rain bands of a hurricane, which are clouds that spin outward, expanding the storm into a larger size. The intensity of the storm can be measured through the Saffir-Simpson wind scale. Storms that reach Category 3, which has a wind speed of 111 miles per hour or higher, are considered major hurricanes. These storms are predicted to cause high rates of property damage, which includes inland flooding and electricity shortages. But what might be the scariest of all about hurricanes is that there are more of them than ever before. Especially in the past half-century, the hurricanes we experience have become longer, more intense, and more frequent. This is especially true in the North Atlantic, and the frequency of the strongest hurricanes, that is, Category 4 and 5 hurricanes, has increased as well. The recent increase in frequency and intensity of tropical storms is partly linked to higher sea surface temperatures in the region where Atlantic hurricanes form and move through. And studies predict that these trends will continue as the climate continues to grow warmer due to climate change, as hurricane intensity and rainfall escalate. Hurricanes have long been one of the deadliest forces of nature, so the fact that they are getting more powerful is terrifying. Over a century ago, as early as 1893, the Cheniere Caminada hurricane was a powerful Category 4 hurricane that made landfall on the small island of Cheniere Caminada, Louisiana, which had wind speeds of over 130 miles per hour. A storm surge of nearly 18 feet decimated the small fishing community, leaving only a few homes intact and killing over 770 of the town's 1,471 community members. For reference, a storm surge is the rise in sea level that is solely caused by a storm. As the hurricane traveled over the Mississippi Delta into southern Mississippi and Alabama, an estimated 2,000 people were killed. Clearly, the Cheniere Caminada hurricane was deadly, destructive, and relentless. In 1900, the Galveston hurricane, a Category 4 hurricane that hit the island city of Galveston, Texas, became one of the deadliest natural disasters in United States history. The high storm tides of up to 15 feet inundated the island, much of Texas's coast and caused about 8,000 deaths, cost $30 million in damage, and left 10,000 residents unhoused as a result of so many buildings being damaged. Other notable storms of the early 20th century include the San Felipe Okeechobee Hurricane of 1928 and the Great Labor Day Hurricane of 1935. Additionally, Hurricane Camille, which took place in 1969, was one of just 4 Category 5 hurricanes to ever make landfall in the continental United States since the start of the century. Hurricane Camille reached the Mississippi Gulf Coast and destroyed the wind recording instruments of the area, so top maximum sustained wind speeds are unknown. The storm brought a storm tide of over 24 feet, resulting in 256 deaths and costing over $1.4 billion in damage. But perhaps the most severe in recent memory was Hurricane Katrina, which lasted for 9 days in August 2005 and caused $100 billion in damage. Hurricane Katrina was the costliest hurricane in United States history and was one of the top 5 deadliest hurricanes the United States has ever seen. The hurricane originated over the Bahamas, moved westward toward Florida, and made landfall there 2 days after forming. Hurricane Katrina then tore through the Gulf of Mexico, growing larger and stronger before again making landfall in southeast Louisiana. Hurricane Katrina was registered as a Category 5 hurricane at its peak in the Gulf of Mexico, but was downgraded to a Category 3 hurricane when it reached Louisiana. The devastation from the hurricane was incredible, with at least 1,245 people dying during the hurricane from the floods it caused. In the greater New Orleans area, 2/3 of the flooding was due to levee and flood wall failure, as the storm surge caused 52 breaches in the levee system, leading to mass flooding. Hurricane Katrina caused thousands to be displaced from their homes and forced to find shelter in poor, makeshift housing like the Superdome. In sum, Hurricane Katrina caused an estimated 4 times the amount of damage that Hurricane Andrew caused in 1992. One of the most brutal, widespread, and recent hurricanes that impacted the United States and Caribbean was Hurricane Sandy in 2012. Hurricane Sandy lasted for 12 days in late October and early November of 2012. In the United States alone, the hurricane had a wide-ranging impact, affecting the entire eastern seaboard from Florida to Maine, totaling 24 states. The tropical storm developed from a tropical wave in the West Caribbean and intensified to hurricane status before making landfall near Jamaica and then Cuba. After that, the hurricane traveled up along the eastern coast of the continental United States, reaching all the way to New Jersey with hurricane-force winds. Hurricane Sandy peaked as a Category 3 storm near Cuba before decreasing intensity to Category 1 hurricane when it hit the U.S. But despite its low rating, the storm had widespread, deadly, and destructive impacts. In New York City, a storm surge caused the city's streets, tunnels, and subway lines to flood. As a result, areas within and around the city lost power and financial markets in the area closed. In New York, 71 people died as a result of Hurricane Sandy, and 233 people died total. For those 12 days, much of the eastern United States was in a state of emergency, with many people living without power and electricity for the weeks it took to repair. The impacts of the hurricane extended all the way to the Midwest, reaching Michigan and Wisconsin, which experienced gale-force winds and high waves from Lake Michigan. Together, the intensive damage caused by Hurricane Sandy cost $75 billion. Other notable hurricanes in recent years include Hurricane Ike in 2008, which hit Cuba and Texas and caused $37.5 billion in damage. Hurricane Wilma of 2005, which went down in history as the most intense tropical cyclone ever recorded in the Atlantic Basin in the same year that Hurricanes Katrina and Rita had already hit. And Hurricane Andrew, which when it struck the Bahamas, South Florida, and the Gulf of Mexico, and Louisiana in 1992, was the most destructive hurricane in American history. When adjusted for inflation, Hurricane Andrew remains the third most costly hurricane in history, destroying 63,000 homes and damaging another 101,000, causing $500 million in damage to oil companies and catalyzing at least 28 tornadoes on the Gulf Coast. When all is said and done, hurricanes seem to be getting stronger, more intense, and are beginning to cause more and more damage. Hurricanes clearly are relentless, unstoppable, and unforgiving storms that wreak havoc throughout the Atlantic basin. You might assume that the deeper into the tropics you go, the more likely it is to come across a tropical cyclone. However, the equator just might be one of the safest places in the world in terms of hurricane risk. Although the equator is warm and tropical, hurricanes rarely form within 300 kilometers, or about 186 miles, of the equator. So what's the deal? Why don't you find earthquakes at the equator? It partially has to do with the Coriolis effect. Hurricanes that form south of the equator spin clockwise, while storms formed north of the equator spin counterclockwise. This is caused by the Earth's spin, which causes the air to be pulled clockwise or counterclockwise in the northern and southern hemispheres respectively. At the equator, even when the air is calm, the Earth and the atmosphere are actually moving at over 1,000 miles per hour, which follows the direction of the Earth's spin from west to east. At the equator, the Earth's circumference is largest, so something on the equator technically moves faster than something that is situated away from the equator. In other words, anything on the equator travels a greater distance in the same time when compared with anything located north or south of the equator on the Earth's surface. When air moves north or south from the equator, it will also travel quickly eastward or westward respectively, at least compared to its new surroundings. This means that air flowing north from the equator will evidently stray to the right, while air traveling south from the equator will seem to move to the left. This is what scientists call the Coriolis effect, which is what causes patches of stormy weather to essentially spin up into a hurricane. More specifically, the Coriolis effect is a force that acts on our atmosphere as a result of the Earth rotating faster at the equator than at the poles. As a result, air currents and storms bend to the right in the northern hemisphere and the left in the southern hemisphere. The degree to which storms bend is impacted by airspeed and the size of the storm system. The magnitude of the Coriolis effect is weak near the equator and gets increasingly stronger around the Earth's poles. Hurricanes feed on their environment to increase their speed and energy, collecting rotation from their environment. Because hurricanes need warm waters for energy, low vertical wind shear, and some background spin to form, it is not feasible for the storms to form near the equator, where the Coriolis effect is weak. Though the waters are balmy and warm, and the shear is low at the equator, the weak Coriolis effect there means there is not enough background spin to cause thunderstorms to form into tropical cyclones. But if hurricanes are unable to form at the equator, what's stopping them from moving across the equator once they do form elsewhere? What leads to this band of relative hurricane safety around the globe? The reason hurricanes don't cross the equator has to do with the fact that the spin of hurricanes is counterclockwise north of the equator and clockwise south of the equator. Because of this, the storm would effectively have to stop spinning, reverse direction, and spin in the other direction to continue across the equator. As the hurricane begins to ingest air rotating in the opposite direction, it would most likely weaken and collapse. The Coriolis effect causes storms to move away from the equator due to what is called the beta drift. The force pushes storms to the north and west in the northern hemisphere, and to the southeast in the southern hemisphere. Because the tropics lack large-scale weather patterns, such as a cold front that might counteract its motion, tropical cyclones are never pushed across the equator. In theory, a hurricane could possibly cross the equator if it was the perfect storm, according to one professor of meteorology at the University of Hawaii. A well-developed storm could potentially be strong enough to continue its momentum over the relatively weak Coriolis effect and reach the equator. But it is highly unlikely and would take perfect conditions to accomplish. As a result, a hurricane crossing the equator is a phenomenon that has never been observed happening in the real world. Though hurricanes rarely form within roughly 186 miles of the equator, there are cases in which the improbable become reality. In fact, in 2001, Typhoon Vamay did just that. The typhoon was seen spinning about 93 miles north of the equator. But scientists say that this is a rare exception that happens less than once in a century. Scientists believe that winds interacting with the island terrain of the Indonesian archipelago may have contributed to such rapid rotation that Tropical Cyclone Vemay was able to approach the equator. Scientists suggest that even if it were possible for a storm to cross the equator, it wouldn't last long in any case. It is conceivable that a storm could cross the equator for a short distance, since around the equator there is fairly small opposing rotation. However, according to researchers, it is unlikely or perhaps even impossible for a tropical cyclone to cross several degrees of latitude into the opposite hemisphere. Ultimately, the likelihood of a storm ever crossing the equator seems to be next to none, given the competing factors associated with the Coriolis effect. However, as climate change escalates and tropical storms become more frequent, more severe, and more unpredictable, it's looking more and more likely that perhaps the perfect storm could eventually arise. And if it does, it might be one of the deadliest of all time. One potential game changer for this phenomenon lies in the fact that as climate change escalates, storms in the northern and southern hemispheres are predicted to get stronger, more intense, and more destructive. There is increasing precipitation associated with storms in more recent years, which is expected to continue into the future. The storm surges associated with these storms are also anticipated to increase with climate change. These changes within tropical storms are associated with increased ocean and air temperatures, as well as sea level rise caused by melting glaciers and sea ice. Scientists report that climate change is increasing the upper limit on hurricane strength and precipitation rates given increasing temperatures of the ocean and atmosphere, providing for more energy to the storm and more intense rain respectively. And it is expected that hurricanes will result in more damage to infrastructure, property, and human and animal life in the years to come. Though climate change does not impact the rotation of the Earth, and thus will not directly impact the chances of a hurricane crossing the equator, the phenomenon is associated with increasingly severe and frequent storms, which means there's a higher likelihood of a rare storm at a low altitude being able to achieve higher intensity and moving toward the equatorial region. In perfect conditions, such a storm may be able to better maintain there, as climate change increases the strength of the storms. But the Coriolis effect makes it highly unlikely for hurricanes to form near or cross the equator, and as a result, the equator and its surroundings is a virtually hurricane-free zone. Areas like Ecuador, Colombia, Indonesia, northern Brazil, Gabon, São Tomé and Príncipe, and parts of Kenya and Somalia may all be some of the coastal areas that are safest from the impacts of hurricanes, all situated around the equator. At the same time, storms that follow a trajectory toward the equator also likely will weaken and collapse due to the Coriolis effect. In some cases, the lack of spin and minimal time to develop while approaching the equator may be irreversibly catastrophic for those tropical storms. In a world where tropical storms and especially hurricanes are increasing in intensity and sometimes frequency, the Coriolis effect is one of the few predictable forces that counters the sporadic, violent, and relentless storms that so often destroy infrastructure and uproot human lives. By late this century, hurricane models predict, on average, that there will be a slight decrease in frequency of total tropical cyclones, but the strongest, Category 4 and 5 hurricanes, will grow to be more common. There is some uncertainty to whether this will definitely take place, but scientists believe that this trend represents the most likely outcome. At the same time, models almost unanimously predict that hurricane precipitation will increase as the Earth's average temperatures rise. This is all due to climate change, which is one of the factors that will most directly impact the creation, frequency, and intensity of hurricanes. With increasingly powerful and more frequent severe hurricanes, the likelihood of a so-called perfect storm increases. Though extremely unlikely, hurricanes near the equator could appear in the near future, although it seems unlikely that one will ever cross it. Hurricanes destroy lives, property, and infrastructure, costing billions of dollars of damage and displacing thousands of people. Despite their unrelenting and destructive ways, it's quite remarkable that the powerful storms are rendered weak and unstable when in proximity to the Earth's equator. The Coriolis effect, which impacts the spin of tropical storms and the planet alike, is a force to be reckoned with, to say the least.